Hello, everyone. This week I'll be interviewing Ferdinand Sauer, who is an employee with us, has been since the start, and he's the development lead on Triton VM. Welcome to the show, Ferdinand.
Thank you very much.
So, what is Triton VM and why do we need one?
Triton VM is a zero knowledge virtual machine. That means it's a virtual machine on which you can prove correct execution of the program that you give to it in zero knowledge. So you can prove that the program was executed correctly, but you don't reveal anything but that fact. This is a little
That
imprecise.
sounds really exciting. Let's get into the zero knowledge aspect later. Why do we need a virtual machine?
The cool thing about virtual machines is that you can execute any program on it, as long as they're Turing complete. But Triton VM is one such machine, and I think most virtual machines are in fact Turing complete. So that means that you can send it any program. For example, your personal smart contract or the smart contract that you want to share with a group of people or the entire world if you so choose. And you're not restrained in any form by what that smart contract can do, unless what you want to do is outside of the realms of computability in general. And then you're in bad luck anyway.
But hang on, my computer can compute arbitrary computations also, and it's not virtual, it's concrete. So why don't we just use people's computers to run blockchains?
The big advantage of a virtual machine is that the rules of the computation are agreed upon by everybody. So it is, in a sense, a virtual computer, and you don't have to have this specific model of computer, but every computer can run this machine, and therefore everybody agrees on what an execution looks like.
Whereas if we were just using people's computers, I'm running Linux, someone else is running Windows, someone else is running Mac, and they might end up disagreeing on the result of some computation.
Exactly.
Why is that a bad thing?
In a blockchain, you want to have global consensus, and everybody should agree on what a certain computation results in. And therefore, the rules under which this computation happens must be agreed upon too. Otherwise, you have potentially divergent views, even though you're running the same program.
And diverging views means
the blockchain.
I think I paid you, but you don't think so.
Exactly. This is something that could happen in that case.
Got it. Okay, so a virtual machine guarantees that everyone has the same view on what actually happened.
As long as everybody is using the same virtual machine, yes.
All right.
And this will, of course, be the case in Neptune.
So how does Bitcoin do it?
Bitcoin doesn't use they use a somewhat more limited instruction set. That is to say, the instructions that you are allowed to use in your computation are somewhat more limited in that it is not intended to be Turing complete. I think there's an asterisk here, and like some things happened recently so that now it is Turing complete. But the intention is that it is not as powerful as that. But still, in essence, there is an agreed upon set of instructions that everybody uses. And I currently am drawing a blank on the name of that. But
the project that showed that Bitcoin was Turing complete?
No.
That's BitVM, by the way.
BitVM is actually the name.
Cool.
No, the name of the set of instructions that you are allowed to use in Bitcoin.
Script.
Yes, exactly. Thank you. It's the Bitcoin script.
And it's not Turing complete, so you can't do arbitrary computations. Is that a bad thing? Do we need arbitrary computations? After all, we're just trying to send money around, right?
Yes, I would say it depends on your use case and what you want to do. If you want to have arbitrary smart contracts, then you need arbitrary computation. If you are just trying to send money around, then you can get away with a more limited set of functionality, that is. Fewer instructions and more restricted instructions. But yes, if you want to have more powerful functionality, then this is generally speaking not enough. And if I understand matters correctly, the reason that the Bitcoin script has become Turing complete by accident is that they wanted to have more features, and they tried to enable selectively a few more features, and then by accident things turned out to be Turing complete. But this might not be a correct account of historic events.
In my understanding of BitVM, what's going on is that the Turing completeness, it's actually a circuit, not a state machine that's being simulated, is only simulated between two parties who disagree about how to close a jointly owned channel. And so you could have someone saying, I updated our balance according to this set of rules, and that set of rules can be arbitrarily complex. And if the counterparty disputes that, they will be able to win the dispute. Well, if they dispute that on solid ground, they will be able to win the dispute using a whole bunch of interactions and a whole bunch of transactions. But it's not Turing complete in a non-interactive setting, which I guess brings us to Ethereum. How does Ethereum fit into this picture?
Ethereum has a virtual machine, famously the Ethereum virtual machine. So they have this anything that can be computed, you can express as a smart contract functionality that Neptune is also going for. However, there the verifiability, which is essential for any blockchain, comes from rerunning the computation. So even though every participant of the blockchain does agree on the computation and how to perform a computation, in order, like, you check whether somebody else has done this computation correctly by running it again yourself. And so if the computation is very expensive, then every individual has to rerun this expensive computation. And even if it is very cheap to run this specific computation, everybody has to do it. So it is duplicated. This work is duplicated across the globe for every participant of the blockchain. So there are certain similarities and there are certain differences, right? It is a virtual machine, and this agrees consensus. This guarantees consensus, but it is produced by rerunning, by duplicating work.
And how does Triton VM fix that?
So this is one of the central properties of Triton VM is that it is a proof system. And in fact, it is a zero-knowledge proof system, but that's the part that is less relevant for this specific question. And but what is more relevant is that it is a succinct proof system. So it is possible to prove correct execution, and the verifying the proof takes very little time. You get a couple of milliseconds for verification time. Yeah. So there is some real overhead for running Triton virtual machine, but the global overhead, the global duplicated work is severely minimized.
The advantage is that the blockchain network doesn't need to duplicate the work. It needs to be proven once.
Yes, exactly.
All right. So aside from smart contracts, is there anything else that in a blockchain context that can benefit from being proven?
Yes, absolutely. So for example, validity of a block is something that everybody in a traditional blockchain, everybody needs to check for themselves. But in a blockchain where there is a virtual machine, a zero-knowledge virtual machine at its core, you can, well, the party that generates the block can prove that this block is in fact valid, and then everybody can just verify the statement. So summarizing, consensus logic can be put through Triton virtual machine too.
Why isn't everybody doing that?
Not everybody has a virtual machine, or at least a zero-knowledge virtual machine like Neptune has. And then the benefits of this are diminished or even none. For example, going back to Ethereum, you could prove the validity of a block using Ethereum virtual machine, but then everybody had to rerun the computation, and this is equivalent to just checking that the block is valid by yourself anyway. And maybe it's even more efficient to check it by yourself because you don't have the specific Ethereum virtual machine, but you can run it on your local machine using more native instructions that are more native to the CPU in your computer.
I'm a little confused though, because on forget about Ethereum, but certainly on Bitcoin, the rules that determine whether a block is valid are actually very simple. It wouldn't surprise me if they take less than a handful of milliseconds to verify. So, what do we gain by pushing them through a Triton VM proof?
Um, if we just look at a single block, you're right, we're not gaining that much. But if we look at the entire chain, we can use a feature of a zero knowledge virtual machine to gain a whole lot. And that feature that I'm alluding to is recursive verification, or something that is known as incrementally verifiable computation, IVC, which means that instead of just proving that the current block is actually valid, you're also proving that the block previous to that one is valid, which in itself proves that the block previous to that one is valid. So you suddenly, by looking at just one block, get an entire chain of proofs that verifies, that attests to the entire chain being valid. And so by just looking at one block, you know that the entire chain is valid. So,
And it still only takes a handful of milliseconds to verify.
That's right. You're just verifying this one proof, which is a handful of milliseconds. Yes. So where Bitcoin, you have to first download the entire chain, which is multiple gigabytes of data, and then run through all of this data to check that the chain is in fact integral. In Neptune, you just look at the one block, the latest block, or one of the latest blocks, and by verifying this one proof, you know that the entire chain is integral.
So we've had smart contracts and blocks. Are there any other applications of Triton VM in the context of blockchains?
Yes, there is. Namely, in the keyword is transaction aggregation, and it means that you don't just have to, as opposed to Ethereum or Bitcoin, for example, a block does not have to have hundreds of transactions in it, but you can, through this recursiveness of proof verification, you can aggregate multiple transactions into, well, you can shrink it down to one transaction in essence, which contains all the inputs and outputs that were in the previously hundreds of transactions.
How do we know that the original owners of the spent funds signed off on that transaction?
Through the proof that is attached to any transaction. So a transaction, through proving that the transaction was a valid one.
Okay, so you prove that the signatures existed on the individual transactions, and that proof allows you to bundle the inputs and outputs into one transaction.
Precisely, yes. And I guess more generally, it does not have to be signatures. It really, like, if the transaction format does not imply signatures, but some other type of unlock mechanism, then you prove that this unlock mechanism was satisfied. So it is very super general.
All right. Does this tie into zero knowledge?
Well, not necessarily. Um, you can do all of this without a zero knowledge virtual machine as long as it has a succinct proof system. But what you gain with zero knowledge is that is privacy in essence. So all of the things that we just discussed, you can do without.
Hang on. Would you please define zero knowledge
Yes,
for us first?
absolutely. Zero knowledge is a property of the proof system, and it means that beyond the fact that I can prove the truth of a certain statement, it also means that the person that this statement is being proven to does not learn anything beyond the truth of the statement. So, for example, if I were to say, this is a transaction that I can spend using this signing key, then if the proof system is zero knowledge, then you don't learn anything about my signing key beyond the fact that it is the valid signing key for this transaction. Yes.
And does Neptune use that property anywhere?
The zero knowledge property?
Yeah.
Well, by virtue of using Triton VM, we use it everywhere, in fact.
But does it need to use it anywhere?
Well, that depends on what you want to say with need, I suppose.
Does the security or privacy break down anywhere if you drop zero knowledge?
Well, privacy certainly will break down if you drop zero knowledge.
In actual fact, the way the UTXOs are unlocked right now is you prove in zero knowledge that you know the pre-image of a hash. But in principle, we could use a signature scheme instead, and then you don't need zero knowledge.
Right.
So yeah, do we need zero knowledge there? The answer is technically no, but since we have zero knowledge, it's a lot more straightforward to just use it. And the second point where we need zero knowledge is where we derive the removal record indices.
Right.
That's a very technical thing. It relates to how you prove that the UTXO that you are spending was not spent before, while keeping secret which transaction generated that UTXO in the first place.
So it allows unlinkability of transactions.
Yes, which is a form of privacy. All right, so what are some applications of Triton VM outside of blockchains?
In principle, whenever you want to prove that a certain computation is what you say produced, what you say it produced, you can apply Triton VM. And some cool use cases that are still probably years away to be really practical, but that are very exciting to me at least. For example, are machine learning applications where you can prove that the model that you have at hand was generated using a certain certain set of training data, or that a certain model was used to generate some image or some text or something like that, and it did not. It was not generated in order to trick you into believing something, or the
It wasn't
applications
tailored
are.
to you. It was the same answer that it would have given anyone else.
Yes, that is more precise. Thank you. Another application that excites me is verifiable or supply chain integrity of software, where you can prove that a certain source code was compiled using a certain compiler to this specific binary that you can then download from the internet. So meaning
Are
that,
you telling me that blockchain does solve the supply chain integrity problem after all?
well, these are applications outside of blockchain, and maybe you can link blockchain into that as well, right? If you put a hash digest of the binary onto a blockchain, then maybe this becomes even more powerful. This could be the case. But I think that putting compiling source code to a binary using the blockchain is probably not its best application, even though it might be theoretically possible.
Understood. All right. Thank you so much for this peek into Triton VM. Where can people learn more about Triton VM?
So we have a website, triton-vm.org. And there, all the important links are listed to GitHub, to the specification of Triton VM if you're interested in that, and even to a small little TUI, a terminal user interface to toy around with Triton VM and like start writing some programs. That you can then prove in zero knowledge. So that's very exciting.
Awesome. Thank you very much. All right. If you'd like to learn more about Neptune, the website is https://neptune.cash. Feel free to ask any questions in the comments below or on the forum talk.neptune.cash. Take care.